Welcome everyone and thank you for joining us for our expert sessions. These are short webinars that take place every 2 weeks and last no more than 30 minutes, bringing you valuable insights from the industry experts. Today's session will be presented by Sonny Solanki, who's Senior Technical Manager at I-Gard. Sonny is an electrical engineer by McMaster University with 8 years of experience in protection systems and relay. Through his career, he has educated consultants and end users on the benefits of integrated electrical protection products into their designs to enhance personal and equipment safety. He specialized in providing commercial and technical support for various projects and applications, including high-resistance grounded systems, low-resistance grounded systems, hybrid HRG systems, and ground fault and arc flash protection systems, resistor-based solutions, and personal protection products. We are excited to have him here today and we appreciate your participation. Thank you, Sonny.
Thanks, Andrea, for the introduction. Today's presentation is going to be talking about UL943 limitations and standards for electrical shock protection in industrial settings. So to start, usually when we're referring to special purpose GFCIs, we would look at UL943C, which is an outline of investigation, not yet a standard technically. And it outlines the purposes that can be used for ground fault circuit interrupters. So these requirements cover ground fault circuit interrupters intended for use in one of the following applications. The first one is where the voltage to ground is greater than 150 volts and equipment grounding or double insulation is required by the National Electrical Code, as well as ANSI/NFPA 70E. And the other one is where the voltage to ground is 150 volts or less and equipment grounding or double insulation is provided, but the use of a Class A ground fault circuit interrupter is not practical, which is like your standard Class A GFCI that trips at 6 milliamp. So ground fault circuit interrupters, there's a special purpose GFCI or SPGFCI, and it's a device intended for the detection of ground fault currents used in circuits with voltage to ground greater than 150 volts that functions to de-energize a circuit or portion of a circuit within an established period of time when a ground fault current exceeds the values established for Class C, D, or E devices. So in this presentation, we're going to take you through what Class A, what Class C, D, and E devices look like and how what the decision-making tree looks like to determine which one you would require. So let's start off with what kind of effects the current can have on a human. So at 1 milliamp, we may experience a threshold of a sensation. Then when we get to 2 milliamps, we can feel a mild shock. 5 milliamps is the typical Class A GFCI trip level, and then 10 milliamps will be the let go threshold. 20 milliamps is typically utilized for industrial GFCI trip levels, and at 30 milliamps, suffocation is possible. 50 milliamps, we have fibrillation. 100 milliamps, the heart can stop beating, and 300 milliamps, we have breathing stopping. 900 milliamps can cause a severe burn, and 1000 milliamps can light a 100-watt bulb. On the graph on the right, you can see how each of these points is graphed, where the current is shown on the x-axis, and the duration of time is also important with respect to how much damage can occur, especially as we get to higher milliamps current. On the low side, we could see that it's not imperceivable, and in this section, there's no permanent harm, but after 200 milliamps onward, we can get involuntary muscular contractions, and then 500 milliamps onward, we can have ventricular fibrillation. And this is taken from IEC 60479-1. Now, this decision tree is going to be the key point of how you decide which kind of class you are using. So starting from the top, we have our system voltage. If the voltage to ground is less than 150 volts and we have equipment grounding or double insulation, we can go with a Class C 20 milliamp rated. which provides protection against ventricular fibrillation. If there's no equipment grounding or there's no double insulation, then you would go with the Class A, which is the 5 milliamp rating, and it provides protection against let go and ventricular fibrillation. Now, if the voltage to ground is over 150 volts and it's within 150 to 300 volts, then you can use a Class C rated device at 20 milliamps. If the voltage to ground is over 300 volts and there's oversized equipment grounding conductor, you would use a Class D, which is 20 milliamps rated, with restriction requiring low impedance grounding path. And then for oversized equipment grounding conductor, if there isn't one, then you would typically use a Class E device, which actually has a higher speed tripping because it's going off a different formula than classes A, C, and D. All of this information is readily available in UL943C for you to analyze. And on the graph here, we've just illustrated where Class A, C, D, and E fall into within the chart that we saw on the previous slide. So according to UL standards, Class C, D, and E GFCIs follow the same inverse time protection curve as Class A GFCIs, defined by Dalziel equation, and the equation is right there. The trip time of a GFCI depends on the amount of leakage current. More current means a faster trip. So as we get more current, you can see that the different devices will trip at a faster rate to meet within the safe zone of this inverse time graph. The inverse trip curve, the reason why it's used is because they want to reduce nuisance tripping from low-level faults, but still ensure that protection for those dangerous ground faults that can happen instantaneously with high level of current. In a typical ground fault protection panel, it comes with a means to break the circuit, so via a circuit breaker or a contactor, and it uses a ground fault relay with a CT that's wrapped around the three-phase conductors and or the neutral to pick up any ground fault downstream of the CT's location. That way, when the load is experiencing a ground fault, here, that ground fault current will circulate back and be seen by the CT, which then is processed by the relay, and the relay sends a trip command to open this breaker to stop the equipment from running for safety purposes for both equipment as well as personnel that could be in close proximity to the equipment. At I-Gard, we have ground fault protection panels that prevent shock hazards by tripping when ground leakage current exceeds safe levels. It's recommended for areas with potential shock hazards to people or livestock, especially for pump, motors, heaters, or similar loads in wet environments like marinas, dairies, shipyards, food processing plants, and breweries. There's models available for solidly grounded, resistance grounded, and ungrounded systems, and the table here indicates our offering. We actually have two variants. One has a 100 amp breaker and one has a 225 amp breaker, as well as we have adjustable trip levels between 6 milliamps to 300 milliamp. Now, in some applications, you may see this useful for welding receptacles, hot tubs and pool heaters, submersible pumps, and also applications where you think that there is a shock hazard and you want to protect personnel that is in close operation with that. Thank you for stopping by on this quick expert session. I hope you learned something, and if you have any questions, we'll be fielding them right now. So I'll just open the question pane here. Is there a Class B GFCI? There is not a Class B GFCI. They just ended up skipping right from Class A to C, D, E, as far as I know. The difference between a GFCI and a ground fault equipment protection, for like ground fault equipment protection is more in line with tripping, but you don't have to follow like an inverse time curve, whereas the ground fault circuit interrupter, it's looking to follow a certain trip curve. So I would argue that ground fault equipment protection is looking to just trip the system within a second or less, but it's more definite time based. What ground fault equipment protection is needed for electrical heat trace circuit? Do you have a device for 30 milliamps? So we do have a device for 30 milliamps. I'll have to check back on what is used for a heat trace circuit, but I believe it should be at 6 milliamps, but I'll double check for you Sheikh Udin. How to ensure protection coordination between GFCIs. I don't think it's something that you just coordinate with. You just have to follow the inverse time curve. I'd have to double check on that to see if coordination is possible between GFCIs, but overall, I'm not 100% sure on that because you have to follow that inverse time curve. Maybe we can make adjustments to be well within the inverse time curve and make it faster than it, but I'd have to double check on that. Do you offer other ampacities other than the example, let's say at 60 amps? So for the 60 amp one, we would just use our 100 amp variant, and we would recommend applying fuses at 125% of the rating upstream of the panel that we provide. How often is calibration needed for your devices? For the most part, probably just some yearly maintenance, maybe just making sure that the breaker's non-sticking. Aside from that, maybe pressing the test button a few times throughout the year during downtimes. Is there a I-Gard part number for the ground fault protection panels? So we have 4 different options. We have GPD, which is our 100 amp circuit breaker, and that has a range between 5 milliamps to 35 milliamps. We have GPAD, which is used for ungrounded systems, and that can trip between 5 milliamps to 35 milliamps. We have GPFJ, which uses the 225 amp breaker, and then GPAFJ, which uses that 225 amp breaker, but is suitable for an ungrounded system. We are in an offshore environment and looking for ground fault equipment protection at 30 milliamps. So if you have a requirement for ground fault protection at 30 milliamps, and let's say your circuit breaker is shunt trippable, I would recommend going with the I-Gard 10C1, which has the low level trip between 10 milliamps to 6 amps, and I would use that to pick up the ground fault and send a shunt trip command to the shunt trippable breaker. If you don't have a shunt trippable breaker, then we can provide our ground protection panel, and that would be reaching that 30 milliamp range. Okay, so you always employ a 30 milliamp GFCI on heat trace. Okay, awesome. So we have some experts in here too. We are in an offshore environment and looking for ground fault reliable solution 20, 30, 40, and 50 amp breakers. I'll send you more information, Sheikh, since you're showing interest, and we'll engage in a discussion via email. We have a few pictures of our devices. They're very small, and we can send you over a few of the pictures that we have. If I lower the fuse of a phase, why does it indicate that there's a fault in the arc relay? I'm not sure what that means. Can you clarify, please? What is the recommended frequency of the trip test button? I think it's site dependent. Some people I know do it once every 3 months, but I'm not sure if there's like a recommended time. Maybe during every downtime, it's recommended to do a test to make sure everything's working as it should. But the actuation of the breakers, maybe that can be done annually or semi-annually. Our panels are, it's one of these two, UL or CSA. I forget which one, but I think it's CSA, and we have UL508, but I'll have to confirm. Same category GFCI despite of milliamp rating and series trip together. So if near load is general purpose and backup to be followed by delay type like S type, am I right? We'd probably have to examine that on a case by case basis, but if you're imposing a delay, it may not meet the inverse time curve. So I think I can get you more information on that, Nadeem. So please send me a message. I'll just give you my email address. Do you have electrical schematic for the GFCI and how I can connection with electrical loads? We do have, it's a very basic schematic like the one I showed you in the presentation, where we just have a ground fault relay, a CT, maybe some control transformers, some pilot lights, and then we'll also have the circuit breaker, but I'll send you more information on that. Is UL943 applicable in Canada? Right now, we're using UL943 since there's no other thing that covers this. The closest thing that we have for CSA is in the 144.1, but that only talks about the 5 milliamp, not the 20 milliamp. So most people in Canada just adopt towards UL943 to figure out what they're going to do. Do we need to do the arc flash study if we use this equipment? I'd have to get back to you on that. I'll check with my VP of engineering and see what he has to say about how a GFCI would impact the arc flash study. Just send me an email on that and I can respond to that separately. Eventually, we will gather all the questions that were pertinent from this session as well as all of the previous sessions and then answer all of these questions and share that information with you. We're just going to be going through these expert sessions, gathering the questions, and then we're going to create a frequently asked question document, which will go through all of the questions as well as their associated answers. Mary, we will share it eventually when we distribute the frequently asked question. All right, I guess that's it for the questions for now. Thanks everyone for joining. We really appreciate your support and consideration as well as the time you take to come out to these expert sessions. Thank you. Have a great day.